All right. So, to finish this problem, we got a few more and then a few identities, so I'm just trying to make sure we get through everything we need to today. On this one, right before I sent you to lunch, I tried to do is it positive, negative, or whatever? Just to kind of reiterate what we just talked about, if we know that beta is in the fourth quadrant, if beta is in between 3 pi/2 and 2 pi, let me actually put this somewhere else. So we know that beta is between 3 pi/2 and 2 pi. So if I divide that by 2, or if I multiply by 1/2 to all of those pieces, that's how I get to that beta divided by 2 is somewhere between 3 pi/4 and pi. That is in the second quadrant, and we know based on all students take calculus, cosine is negative in the second quadrant. So that's how I got negative there. And I know that that was kind of a quick explanation, but we'll do a little bit more with that.
That was in.
So beta is in quadrant 4, but we're doing half of beta, so that's gotta be somewhere in quadrant 2. So we multiplied everything by 1/2 or divided it by 2. So that was my quick explanation of that. I want to keep going because we've got a few more of these guys that we got to do. Okay, everyone okay with that? All right. Oh, sorry. We just did that one. We're still on letter D. Let's jump up and do letter C. We'll kind of work backwards because we haven't done any double angles yet, and I do want to do some double angles. Charlie just clapping next. We're going to do cosine of 2 alpha. Okay. Now go to your identity sheet and find your double angle for 2 alpha or for cosine. So if I go backwards, this is the closest place in my notes it is. Do you remember how cosine of 2 theta has a bunch of different ones that we can use? As of right now, you have a lot of choices. You can really do anything. You can do any of those 3 and it will work, and we should get the same answer. However, one thing that might be smart to do is use the trig function that they gave us. So at the top of the page that you're on, what did it say that they gave us about alpha? Did they give us sine or cosine? They have a sine. So I would probably do the 1 minus 2 sine squared. If some reason I messed up and my cosine is wrong, I don't want to use a wrong answer to find a new answer. So I'm going to do 1 minus 2 sine squared theta because I know that that's going to be the correct piece that they gave us. 1 minus sine squared alpha.
Isn't it 2 sine?
Oh, is it 2 sine? Is that what the equation says?
1 minus 2.
Okay, yeah. That's my bad. 2 sine squared. Okay. Now we know what sine of alpha is. What is sine of alpha? They gave us that in the direction. 3/5. So I'm going to replace sine of alpha or sine squared alpha with 3/5 squared. So I've got 1 minus 2 and then 3/5 squared. We're taking the sine of alpha and squaring it. What do I do first? 1 minus 2, 2 times 3/5 or 3/5 squared? Good, squared. 1 minus 2 times 9/25. When I do 2 times 9/25, yeah, bring that negative with you, very good. And do I multiply the 9 and the 25 or just the 9? Just the 9, good. I'm just trying to get a lot of common mistakes out of the way now so we don't have to make them on our own later. So 1 minus 18/25. What can I do next? Common denominator, so let's multiply by 25 on top and bottom here. So I've got 25 minus 18/25, which you might have already done in your head. What is that? 7/25. Now, notice that there's no plus or minus here. That is taken into account already. So we just take it as is. That's my answer. That's my answer. Okay. All right, we've got a couple sum and difference ones up here. Do you think we can maybe try those on our own?
Just like.
You wanna do the tan one, Tanner? I
I
can
wanna
do-
do it in there.
Okay, you know how to do it. Okay, good. What a thinker, what a giver. Okay, we'll do the tan one. We'll just keep working backwards. So we're gonna do tan of alpha, same sign, minus tan of beta, all over one opposite sign plus tan alpha times tan beta.
It's just a normal.
This is your tan sum and difference.
Yeah, it's not the double.
Not double, not half. Yep. I don't know if I would call it normal though, because it's not like we've been doing this for like weeks and weeks. We just learned it the other day. All right, now we can go back up to our pictures and figure out what tan of alpha and what tan of beta is. So tan of alpha, we don't even have to solve anything. We should just be able to look at the picture, right? What would my tangent of alpha be? Good, 3/-4, make sure that there's a negative involved somewhere. -3/4, 3/-4, I don't really care. What about tan of beta?
-12, or -12 this.
-12/5. Everyone agree with that? Awesome. So now where we see tan of alpha, we're gonna plug in -3/4. Wherever we see tan of beta, we're gonna plug in -12/5. The only annoying part now is we're gonna have a lot of fractions that we're gonna need to add together. We're gonna need to simplify as best as we can. So we've got -3/4 minus -12/5 over 1 plus -3/4 times -12/5. I'm gonna kind of do two steps at once. I want to get the numerator to be all one fraction. So I'm gonna multiply 5 on the first fraction and 4 on the second fraction. Is everybody okay with that? So I get -15 plus 48 all over 20. You may go a step further and have already done -15 plus 48. I just couldn't do all of that steps all together. And now I've got 1 plus negative times a negative becomes a positive. The 4 and the 12 make a 3, so I get 9/5. Okay. Now I want my denominator to also be one fraction, so I'm gonna multiply by 5 on top and bottom there. And I'm gonna clean up my numerator, so 15 plus, or -15 plus 48 gives me 33 over 20. And then that denominator, 5 plus 9 is 14 over 5. What do you think we do next? Multiply by the reciprocal, so times 5/14. And got a little bit of canceling here. 33 and 14, I don't think can simplify at all, can they? Nah, so it's gonna be 33/4 times 14. 56. All right, now that we've done tan together, do you think you can do sine by yourself? Bless you. Try that one by yourself. Right, I will give you a little piece of advice, as tempted as you might be to cancel something out, so like once I plug in my values, I was gonna multiply and I was like, oh, great, I've got a 5 that I can cancel out. I can't cancel anything out on the other side, and we're eventually gonna wanna add these fractions together. So I'm gonna fight the urge to cancel, and I am gonna keep it 5 times 13 in the denominator. So I've got 15 plus 48 over 65 maybe? And then I add those together. All right, we doing okay with that so far? Yeah, I will tell you one big mistake that we do is we just forget to use our sum and difference, our half angle or double angle theorems. Sometimes we'll just do sine of alpha plus sine of beta. You can't just do alpha plus beta, you have to do the entire formula. So that's just one key that I'm gonna give you is that if you find that you didn't use a single half angle or a single double angle on your test, then you did something wrong. I wouldn't teach you something like this and us not do it. Okay. We'll talk more about what to expect on the test next week, but we've got a couple of these simplifying solving problems to do. So we're gonna do these for a few more minutes and then we will go to work on our homework, I guess. So I think these problems are like all almost identical. We're not gonna do letter C, but like to me, like 3A and B look a lot like 4A and B. Do you notice what the only difference between 3 and 4 are? It's what angle, how we want our angle written. It's degree versus radian. So they're all about the same. I think there's a little bit more space on 4, so we'll do these, but again, you could do it if I said equal to radians or equal to degrees. Okay, so let's just jump backwards. Let's look at a few from 4. Okay. So these are the problems that we've done in the past where we're solving. So we need to get it factored out. So we've got something equals 0 and something else equals 0. So I'm looking at letter A on number 4. And I've got, okay, cosine of 2x plus cosine of x. First thing, you can't just take a cosine out of everything because this is cosine 2x, not cosine squared. Okay, so let's simplify this cosine 2x out. Go to your identities, cosine of 2x. Let's see, where am I at? Oh, mine already here, perfect. Which one of these do you think it would be the best to plug into what we're using right now? Good, 2 cosine squared theta minus 1. That way we don't bring another trig function involved, we just have cosines in here. So I'm gonna replace 2 cos 2 theta with 2 cosine squared x minus 1. And I'm still gonna have that plus cosine x. Oh, what do you notice here? Can't do that because I have a 1. So I've got cosine squared, I've got a 1, I've got a cosine. What if I reordered it? What if I put it at 2 cosine squared x plus cosine x plus 1? Does that look like something we've done before? Yeah, this is where we take that cosine out and we can replace it with a 1.
Should be minus.
Should it be minus 1? Yeah, thank you. So at this point, if you like the cosines in there and you can factor it that way, that's fine. I think it's hard to visualize that. So I'm gonna go ahead and change that to be 2x squared plus x minus 1. Now that looks like a much more factorable problem than the other ones does, doesn't it? Doesn't that look more factorable? Mm-hmm. So factor that one out. I think that's right. Sometimes I have to double check my factoring, but I think that's good. Do you remember what we do now? Plug that cosine back in. So now I have 2 cosine of x minus 1, and we can set them equal to 0. I heard someone say that over there. We could plug cosine in and set them equal. I'm sorry, what? It was you, Danny, okay, good job, Danny. And so then we just use both of those expressions and we solve and we figure out all the angles that work, so. Once I set it equal, I've got 2 cosine x minus 1, I'm gonna add 1 to both sides. I'm gonna divide by 2, so I get cosine of x equals 1/2. So I asked myself, okay, where do we have a cosine of 1/2? 60, good. And we want all the places that we have a positive 1/2. That's a pi over 3, and then where's the other place that we have that? By pi over 3. If you're doing degrees, that would be 300. All right, then I've got cosine of x cosine of x plus 1 equals 0, so I'm gonna minus that x from both sides, so I get cosine of x equals -1, and I ask myself, where do I have a cosine of -1? -1, pi. So we want to know where do we have an x of -1, and that is only at pi. We'll just do one more for kind of sake of fun, I guess. Let's just do letter B. I know we're all having a blast, aren't we? I do think this one should be easier. That one was the harder one. I did not expect to do the harder one first, but I got partway through and I was like, well, we're too committed. We can't stop. And we're capable. I just didn't want to do it. That's how school works. We're in it. We gotta finish. Okay, what do you think we should do first? Sine 2x equals 2 sine x. Move it over. Move everything to one side. Put everything on one side to start. Now, I know what you might be tempted to do, but I don't want to do that yet. I'm gonna ask you to go look at your formula sheet. We're on 4B. Oh, that's okay. What does it say for sine of 2x or sine of 2 theta? Good, 2 sine theta cosine theta. I have replaced my thetas with x because this problem used x, and that's okay. That was my only option. I had nothing else to plug in, so I have to plug that in. But that's fine, because now, do you see something that I can take out of everything? A sine x? I think a 2 sine x, good, even better for us. 2 sine x can come out of everything. So I'm left with cosine of x minus 1 equals 0. And now what? Set of equal to 0. I'm gonna kind of bring that over here because I'm running out of space. So I'll do 2 sine x equals 0. So when we divide by 2 on both sides, we'll get sine x equals 0. Then I ask myself, where would sine x be 0?
I would do
Sine is y.
0.
Oh, 0 pi. If we were doing it in degrees, we'd have 0 and 180. And then we also have to do the other part. We have to do cosine of x minus 1 equals 0. And then we add 1, cosine of x equals 1. And that's at x is at 0. So I don't need to write that again. I don't think.
That's what I do the first part.
Say again.
You go back to I get that.
Oh, right here or even farther back. So first I moved everything to one side, and then when I have a 2x or a x divided by 2, you want to use your angles, your angle formula.
Oh, is that
And that's on your identity sheet. So that's not something that like I expect you to know, you just have to read it off your sheet. I don't know, did I tell you guys you'll get an identity sheet? Did I tell you get a filled in unit circle? Okay, sorry, it's been like a long couple days, so I just forget what I've told you guys. I hope to have an example of that on Monday so you can see what yours looks like, because I know you've been practicing with yours. I want you to be familiar. Okay, this is where this is where that is, so that it's I think it's very clear and clean, but I want you guys to also feel good about it. This is a test. We have 5.4 homework that's due next class. We got a few more minutes in class, so you're welcome to start on that.
Bye.